I'm Alex, and together with my colleagues, Unruh and Zhuang, and our advisors at Kansas State University, we've been working on ANCOR, a framework that compiles abstract specifications into concrete systems on different cloud platforms. So, in general, if we're thinking about moving, current IT deployments to cloud infrastructures or building new ones on cloud platforms, companies, network administrators, users in general, they look for pretty much the following features. They would like to have a lot of flexibility. That means that they should be able to access their raw resources if needed, computer resources, storage, bandwidth. It would be great to have, automation. So the automation should be non-scenario dependent, so I can specify whatever IT system I want, and still have a way to automatically deploy it and maintain it. On the other hand, dynamic cluster expansion and contraction would be also a really great thing to have, right? And then migration, right? We don't want to just be stuck with one vendor. We would like to take our specification and deploy it on other cloud infrastructure, and it would be great if our specification will capture the infrastructure and the application requirements. Okay, well, let's look at current cloud offerings. And current cloud offerings, they allow users to decide how much management they want. So we have three options: infrastructure as a service, platform as a service, and software as a service. If we're looking at infrastructure as a service, solutions like Amazon Web Services, AWS, or OpenStack, they allow cloud users to access the raw resources, whatever they need: compute, storage, bandwidth. However, it forces the users to manage the software stack on their cloud instances at a very low level. This gives users a lot of flexibility. That's really great. But it also allows users to misconfigure machines, to badly configure them, and then these things raise quite a few concerns, especially from the security perspective. On the other hand, offering failover and automatic scalability, it's very hard for cloud providers, because usually this is application dependent, and it is very hard to replicate the state and the software state and for each application. Then we have software as a service, or on-demand software. This provides pre-configured applications to cloud users, so you cannot really go wrong there with configuring your application. You can choose from a predefined number of templates. Usually it's hard, to cover with these templates all user needs, but let's say this happens, then users will have to face the vendor lock-in problem. Then we have platform as a service, which often is viewed as a compromise between infrastructure as a service and software as a service. However, it also inherits to various degrees the limitations of both. For instance, we can easily get locked into a PaaS vendor, like in SaaS, and on the other hand, we still have to configure the application ourselves, like in infrastructure as a service. So we are proposing an abstraction that captures what the cloud user needs instead of the low-level details on how to implement those needs. So basically, we want a separation between what the requirements are and how they are implemented. Well, this sounds really great, right? Another abstraction. However, our proposed solution also includes a process that automatically compiles the abstraction into a valid concrete system. So we packaged our proposed solution in the ANCOR framework. The key behind our approach is to abstract the functionality and structure of IT systems into a model that is used to generate and manage concrete systems. So what the user needs is captured in a high-level abstraction. So we can see here the operations model. So we're capturing the user's needs in the requirements model. The requirements model is a high-level abstraction that captures the dependencies between the services and the clustering approaches. So basically, we're able to capture the dependencies between services at the whole system level. The requirements are transformed into a concrete system, and all the low-level details are stored in the system model. So the system model pretty much is mirroring whatever is deployed in the cloud infrastructure, and it's always updated when a change happens on the cloud infrastructure. The compilation process, we have two main components here. We have the compiler and the conductor. The compiler is responsible for populating the system model with the low-level details so that the system model reflects the user's requirements, and also makes sure that, that the system model is always up to date. And the conductor is our component that interacts with external units like configuration management tools, and we have an orchestrator and the OpenStack API in this case. We are currently using Puppet, OpenStack, and mCollective in our current prototype, but other configuration management tools like Chef, CF Engine, Ansible can also be used, and AWS can replace the OpenStack platform. Okay, let's look at an example, right? So for example, if a user wants to deploy a scalable and highly available e-commerce website that adopts a multiple layer architecture with various clusters of services, so we have a cluster of load balancers, a cluster of background workers, web applications, database with database master and slave, and messaging queue. So we can, in this example, we chose for the load balancer Varnish. So Varnish implements the load balancer. The web application, it's a little bit more complicated because we are using Rails supported by Nginx and Unicorn workers. So this is the specification for our e-commerce website. Basically, this is the ARML specification, we're calling it, and it stands for ANCOR Requirement Modeling Language. It's basically a YAML-based declarative language. So in ARML, we are declaring IT systems in terms of goals and roles. A system can fulfill several goals, and the goal can be viewed as the business objective, overall business objective. A deployment can have multiple goals. The roles are the means that support the implementation of the fulfillment of goals. If we're looking at the role can be viewed as a single unit of configuration. Basically, it represents a group of similar configured instances that provide the same functionality. In the role specification, the user can point a role to the specific implementation, pretty much to the CMT, to the configuration management tool building blocks. In our case, the default implementation corresponds to Varnish. And we are using exports and imports to capture the dependencies of a service with other services. So for instance, our web balancer exports an HTTP resource, so a single port, and it happens to be port 80, and then it imports, in order to function properly, it has to know where all the web applications are. Okay, a brief overview of the workflow. So we're taking the specification, we're passing it to ANCOR, then the specification is stored in the requirements model. Third thing, it's the compiler comes into play and computes the low-level details of the systems and stores them in the system model. Then the deployment starts, and ANCOR uses the cloud APIs, the cloud and the CMT APIs to deploy our system on the cloud infrastructure. Then we're making sure that the system model is always consistent with the deployment. So if we're expanding a cluster of services here, or we're contracting it, or whatever changes we're making will be always reflected in the system model. So some of benefits of using ANCOR, being able to capture everything in a specification, infrastructure, and especially applications requirements, makes it possible so that we can just take the specification and port it to different infrastructures. We always have an up-to-date picture of the dependencies. We can build highly dynamic systems, so pretty much we can support moving target defense systems, so continuously changing systems with minimal downtime, if not zero sometimes. We can have automated fine-grained firewall configurations, automatic security assessments, performance evaluations, and we can also create customized platform as a services PaaSes. Our current implementation is available on GitHub, so if you want to look at for more information how we did it, you have all the information here. Okay, in conclusion. Separating user requirements from the implementation details has the potential of changing the way IT systems are deployed and managed in the cloud. We are proposing ANCOR, a framework that captures high-level requirements and translates them into a working IT system on a cloud infrastructure. This is the URL for our current prototype. Our LISA hours, office hours are from 4 to 5:30, so we'll be very happy to talk to you if you have further questions. Thank you very much.
Hi, Patrick Cable. Whoa, hey. Hi, Patrick Cable, MIT Lincoln. I was curious if you had done any analysis along some other tools in this space, specifically one that comes to mind is Terraform. Kind of does some work that seems along these lines.
Yes, Terraform, we looked at, actually I have a slide here. OpenStack Heat and CloudFormation. Terraform is greater because it's cloud agnostic, so you can specify the infrastructure requirements from different clouds. These solutions, they capture the infrastructure requirements.
Gotcha.
They do not capture the software requirements. So what we can do here is instead of using, for instance, our the cloud API directly, we could use maybe Terraform or Heat or AWS to actually pass the infrastructure requirements.
Okay, great. Thank you.
Thank you. Thank you.